We are going to continue with the chemical reactions unit, so please get out your notebook, label your notebook with today's date on it, and then write predicting products. So we first want to remember and review the law of conservation of matter. We've talked about it a few times now, this unit and in the past. And this law states that in a chemical reaction, the quantity or amount of each atom does not change. Each side of the equation must have the same number and the same kind of each atom. So if one side has 2 hydrogens, the other side will have to, the products will also have to have 2 hydrogens. And if the reactant has 2 oxygens, the product has to have 2 oxygens. And this is what you're doing when you're balancing chemical equations. But we need to remember this as we are learning about predicting products. So start by writing down these 4 steps that you will need in order to predict products. So pause the video, write these down. I'll say them out loud as well. Step number 1 is determine the type of reaction. So we're going to look at the 5 types of reactions that you learned about last video. Number 2 is you'll predict the products based on the type of reaction. And we always want to ask ourselves the question, are diatomic elements present? And we'll talk about that in 1 minute, what a diatomic element means. Next, you need to balance your equation and of course show all of your inventory, and throughout this whole process make sure you're checking your work and you're showing all of your work as well. So we just said the word diatomic elements, and what does diatomic mean? Well, if you think of the prefix di, that means 2, and atomic means atom, so we're thinking something about 2 atoms. Well, there are 7 elements on the periodic table of elements that exist as molecules. They always need to be with something, with another atom. So sometimes it could be just another atom of the same type of atom, or it could be a different atom. So for example, hydrogen is a diatomic element. So if you only have hydrogen by itself, it needs to exist in H2. However, you could still have hydrogen with another atom and only one of it. So for example, HCl, we've talked about a lot. You only need 1 H and 1 Cl, but as soon as hydrogen's by itself, it needs to be with 2 of it to make it a molecule. So write down these 7 diatomic elements. And this is because with 2 atoms, they can fill their valence shells effectively. So the 7 are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And you will get super used to seeing those, but they make that shape, that upside down L on the periodic table of elements, plus your hydrogen. So we're going to look through predicting products. So the first step we said was to identify what type of reaction we have. So so we're going to look at how would I be able to tell that? So if it's a synthesis reaction, there will be 2 elements or 2 covalent compounds in reactants. And I'm going to go through each of these slowly. So for example, here we have 2 elements, or it could have been 2 covalent compounds in the reactants. So I know right away it's a synthesis, and I'm thinking, okay, synthesis is bringing 2 things together based on what I know from predicting products. So therefore, magnesium and oxygen are going to need to come together. So I will have a compound of MgO. Well, I need to figure out what are the charges on Mg and what is the charge on O so I can have the right compound. Well, this one is super easy. Because I look at my periodic table of elements, figure out that the charge on magnesium is +2 and on oxygen it's -2. So I crisscross this ionic compound, and this is just review from previous sections, and thus my compound here is MgO. My next step said to balance my equation, so I show my inventory. Okay, my magnesiums are balanced, but my oxygens aren't. So what could I do? Well, I could add a coefficient of 2 because I can't change the subscripts. So add the coefficient of 2, but then that's going to change my magnesium, so I'm going to have to add another coefficient of 2. So once I balance it, I'm going to add 2 Mg plus O2 yields 2 MgO. And I've shown all of my inventory. Pause the video and write this example down in your notes, please. Our next one is decomposition, and decomposition is breaking down. So if we see only one compound in the reactant, we're going to know that it's a decomposition. So for example, in this case, we only see one compound in the reactant. And right away I'm thinking, okay, I'm going to have silver and bromine, but we have a diatomic present, so since bromine is a diatomic, it's going to have to be Br2. So this is an example of a time you're going to add subscripts when you're predicting the products. So we have Ag plus Br2. So next we need to show our inventory. So I have 2 bromines on the product side, but only 1 on the reactant. So I know I'm going to have to add coefficients. So if I were to balance my equation, I would add 2 coefficient in front of the AgBr and 2 in front of the Ag. Make sure this is in your notes, then we're going to go on to the next one. Single replacement. This is when one element gets replaced by another. So if we see an ionic compound in a single element in the reactants, like this, we know it will be single replacement. So my 2 cations are going to replace each other in this case. So Mg is going to kick Cu out. So I'm going to have Mg and Cl together. So I'm going to need to figure out how many of each do I need. And I do that by looking at the charges. So if I have Mg has a +2 charge, Cl has a -1 charge, crisscross the charges, I'm going to need 2 chlorines. So the compound will be MgCl2. And then I still need to account for my copper that was kicked out, that was replaced, is now by itself. So we have MgCl2 plus Cu. Next I need a balance, and I look, oh, great, everything is balanced, we are good to go. And I only, to answer a commonly missed question, copper doesn't have a 2 here because it's not a diatomic element, so we're good with that. And everything else looks great. Check my work, good to go. Make sure this one is in your notes. Then we're going to talk about double replacement. So double replacement is if I see 2 compounds, typically both ionic in the reactants, we'll be able to see that. So for example, here are 2 compounds in the reactants, sodium hydroxide and HCl, hydrochloric acid. So I know, okay, the Na is going to form, so the plus cation is going to form with this anion, and this anion will form with this cation. So I'm going to have NaCl and HOH. So look at my charges. Na has a +1, Cl. This should not be there, sorry. Na has a +1 charge, Cl -1, so it's just NaCl, so again, ignore that. And then HOH, hydrogen has a +1 charge, O has a -2 charge, so we have H2O. And this is correct there. And then show my inventory, and I see, this is a mistake as well. This should just be 1 oxygen, so we're good to go. Everything is balanced. We're happy. So this should be 1 there. Apparently I did not do a good job checking my work, so make sure you do a better job of checking your work. Next is combustion, the fun one. This one is really easy to identify because if we see a carbon and a hydrogen together and oxygen in the reactants, we know it's a combustion. And this will always, in this case, yield, in our class, yield CO2 and H2O. So that's something you got to remember is if you have a combustion, your products automatically are going to be CO2 plus H2O, but then you will need to balance it. This looks kind of scary to balance because I have like 10 hydrogens on the reactants, 2 on the products. Kind of crazy, but if you were to take your time and just add things little by little, follow our rules, you would get a few coefficients. So that would be your correct answer. So make sure this one is in your notes, and then we'll continue on. We have a few example problems for you here. Make sure that you follow the steps to classify the equation. So tell me exactly which of the 5 it is, and then predict your products, and then balance your equations. Make sure to show all of your work with showing inventory and all of that fun stuff while you work through this. Make sure to submit a picture of all of your notes completed, as well as these 3 practice problems. I hope you have a great rest of your day.